Good morning. It is a pleasure to speak today. I would like first to thank the organizer for inviting me. I would like to speak today about playing in virtual reality. Virtual reality is in fact based on three concepts, which can be organized in a triangle. It means that first, it should be real time. This means that when you have an action, it should immediately modify the state of the space. The second thing is that we should feel that we are in the 3D virtual space, which is the immersion aspect. And the third thing is the possibility of moving or manipulate objects. This means to interact with the virtual world. So it is the interaction. Now, one aspect which is fundamental in virtual reality is the fact that the computer knows, in fact, what we are doing. And this means that it's not only that we can see the virtual space, but it's possible to know what the user does in the virtual space. And for this, it is important to capture the motion. And to capture the motion, you have mainly the hand and the upper limbs. So to capture the hands, we can use a cyber glove, and to capture the body part, we can use a depth camera. So you see here a typical example where we see somebody with a data glove, and there is also a depth camera, and we can in fact capture the gestures without object or with an object. Now when we get the information from the glove, which gives the information about the joints in the hand, and the camera that gives the information on the upper body joints, then we can mix them. This means to merge them, and from the two information we can get only one, which is depending on the hand and the body. So I show you now a movie where you can see this kind of gesture recognition.
I'm going to show you that nothing has a three-dimensional visual capacity. She can gaze at me well rested and moving. Now you can see it. The lesson is started. I will say hello to her by shaking hands. If I'm too far away, she will let me know.
You are too far, please come closer.
Okay, I will come closer.
Nice to meet you.
Nice to meet you too. Now I will show other gestures.
It is great to see you so confident. What is your question? Why do you disagree? Thank you for your praise. Why do you stop me? Well done. You are successful. Okay, we finally reached the agreement. Please turn off your phone. You can have a drink, no problem. Please take your time and read it carefully. If you need time to take notes, I can slow my presentation.
Now class is over. I will say goodbye by shaking hand again.
Yeah. Okay. I hope you will remember the lesson.
Thank you. Okay, that's all.
Now if we look at the hand gesture recognition, we have a hand and what we want to get is in fact the joints. It's called hand pose estimation. It's important for human-computer interaction, but it's also important in virtual reality and augmented reality applications. You see a few applications. Now, what is the problem? In fact, we have as an input a depth image containing a human hand. And what we want to get as output is an estimation of a joint location, which is a hand pose. You can see here a movie where we have the estimation in a simple depth image using deep learning. So here what we can see is that we have the original 3D points, the ground truth, we have our method, and another method which is by Thalmann. You can see that the multi-view method gives much better results for the fingers. Of course, the palm is not in fact processed, so it's just you should look only to the fingers. Now we see here the RGB image, normal from the camera, the depth image, an estimated hand pose, and of course you have the segmented hand. You see, each time for each image, we can see exactly the depth. And then we see how the fingers, inside the fingers, you have the joint. Now in the second movie, we see how it can be used for virtual reality. You see, we have the depth camera, we see the helmet, and then the user is manipulating objects in the 3D environment using only the hand. Or here, we see that the user can paint inside the virtual space directly, and we see the result, and also we see on the joints using the neural networks. You see only use of the hand. And of course, we can use two hands. You see another example with an application. Here, we see the hand, we see also the depth image, and we see exactly like what we can do with the fingers. Actually, everything is recognized, as you can see. Here is another example of
Hello. Welcome to the rock, paper, scissors
recognition.
game. Let us start the game.
Now,
1, 2, 3.
you see, this is a very famous
Congratulations,
game
you won.
that we use. So it's to recognize
Let me see who wins this time.
the
1,
gestures.
2, 3. Oh, it's a draw.
You see,
Let me see who wins this time.
paper
1,
game.
2, 3. You have lost. Better luck next time. Here we go again. 1, 2, 3. Oh, you have won. Let me see who wins this time. 1, 2, 3. You have lost. Better luck next time. Okay, so get ready. 1, 2, 3. Congratulations, you won.
Now I want to show you another thing, which is with head mountain wind. The head mountain wind is something completely different. It means the head mountain wind means that we have in fact a device that can simulate the wind, and then the user have really the impression that he is in the wind. You see there are a few fans, and then we can see a rotation around the head. That's the reason why we call this head mountain wind. Now is another application where we can use, in fact, the vibration. This means that we have in this is a tactile aspect. I mean the tactile aspect means that we can feel a feedback. For example, here it was used in the solar impulse. We have contributed to the solar impulse, which is a famous airplane, which is based only on the sun light. And this is interesting because it's for pilot. It should have really little weight. It cannot have any device, and so we have developed a kind of vibro-tactile feedback in this belt. Now, if it's part about tactile, we should also speak about haptic. Haptic means that it's when we can feel forces. This is extremely important because in virtual reality, what we have very often is object, and we can in fact penetrate the object. This means that objects are supposed to be solid, but in virtual reality, they are never solid. So which means that we can enter the fingers inside the object. To prevent this, we can develop a haptic feedback. And this is only possible with a very heavy hardware. Like you can see here, where in this chair, all this device allows to feel in the wrist the forces. So you see we have the hand, we can see this hand visually, but also we have a mass spring hand which is able to calculate the force applied on objects. So here you can see a movie. You see the movie, and this is that we have the hand, and we see that when we, with the device, we try to penetrate inside the table, we can feel the force. It's not that we cannot enter into the table, but we can feel that there is a table. And this is the main thing. Here we can feel that we touch the object, and we can perceive how the object is because of the force that we get. Now, virtual reality is something very important in terms of technology for gaming and sport. Why? Because sometimes it's difficult to exercise alone. And this is a way of exercise when you are alone. Now, we will see a sport which is popular in the south of France called pétanque. And here is a virtual pétanque. You see, the goal is that you can see the player is throw away a small ball, and then it will use heavy balls in metal, and the goal is to try to be the nearest of the small ball. So it's really the target. Oh, not good. Okay, now it will be better, I'm sure. Yes, oh, perfect. And here, you can see, no, next one. Yes, this is perfect. Clear, really. And now another one, perfect. And we have a last one. Now, this is the main part of our presentation, is that virtual reality is an ideal technology for playing together in collective games. You see, for this, we will take an example, which is an old example on tennis. We made a tennis between Geneva and Lausanne with two avatars, which are players, and one autonomous referee. You can see now on this movie that we have a first player. In fact, this is our daughter, and she is playing with a guy, an assistant in the laboratory in Lausanne. They are playing together, but what we can see is that when they play, we can see them as virtual humans, so they are avatars, is what we see on the image on the screen on the right up. And then we have also the vision of the first player through the helmet in the image which is on the left below.
En bas et à droite, nous sommes à Lausanne. En fait, nous voyons
You can also see in the image here that there is another character, and this is in fact the referee. The referee, Marilyn, is looking at the game, watching it, and deciding the points.
40, 30.
Also, you can hear the sound in French because it was in Geneva.
La voix que vous entendez, c'est celle de Marilyn, l'arbitre de la rencontre.
So you see here the game again, and this is the referee. Now we can see an immersive volleyball with computer players. This is a new project, a recent project from China-Singapore project, in fact. We see here that it's a simple and generic game with multi-user. There is a full body capture. We use the HND to reconstruct the head rotation, and it's a multi-party game. So we see for the input, there is the Oculus and the depth camera. The Oculus is to estimate the head pose, and the depth camera to get the user skeleton and position. This is the body tracking. The output can be on Oculus, in a cave, or on a monitor. It's a multi-party VR framework. This means that we have a client server, but also spectator can just see the game without participating. Now we can see an example scenario, which means that we have a multi-user volleyball game. We have two teams with 6 players, interaction between the player using the ball, and a combination of computer and real player. Here we can see 2 real players represented by the avatars, and the green players are autonomous or computer players. There is nobody behind. Now we can see an example of the movie. You see how they play, they can catch the ball, they have the normal gesture of players, and then they can possibly win. See, and then start again, yes, and this is the result. Now we can also have gaze interaction and sound. We have the sound of the ball, for example, on the floor, or even on the net, or on a player. Here we have the pick. We can pick the ball. We see on the player how it can pick the ball. It's important because the ball can be on the floor sometimes. And here we see other interaction, for example, the collision avoidance. Then finally we have an audio feedback. It means we can introduce 3D spatial sound. This means that we have a unique sound based on the contact with the player, with the ground, or with the net, but also based on the type of action. It can be underhand, overhand, or spike. And there is a background commentary when the game state changes. We can see here the demo.
Team Blue play the next serve. Blue scores a point.
You have seen the sound. And finally, this is a demo with public.